Today we're going to start a section on axial contours and rest preps. We will do numerous exercises which should prepare you to do mouth preparations for the completion of a successful removable partial denture. You'll remember that a rest is any unit of the partial denture that rests on a tooth surface for the purpose of providing vertical support for that partial denture. It has to be located on a tooth surface that has been prepared to receive the rest, and that preparation is called a rest seat. There are two kinds of rest. A primary rest is a rest that's part of a clasp assembly. Then the second type of rest is an auxiliary or a secondary rest, which is one that is responsible for additional support or indirect retention. Additional support, an example of that would be a real long bar that is located between two widely separated abutment teeth, and you might put a rest somewhere in between to provide additional support for that bar. The primary purpose of a rest is to provide vertical support for the removable partial denture, but it also accomplishes the following. It maintains components in their position. It maintains established occlusal relationships by preventing settling of the RPD in that posterior area. It prevents impingement on the soft tissues by the metal framework. It directs and distributes occlusal loads to the long axis of the abutment teeth. It resists displacement of the framework in a lateral direction, and it maintains the retentive clasp arm in its proper position. There are four components of a clasp assembly. First, you have the rest, the direct retainer, the reciprocal component, which may be an arm or plating, and the minor connector, which leads up to the rest, which is usually represented by our guide plane. Rests may be placed on sound enamel or in any restoration that has been proven scientifically to resist fracture and distortion when a load is applied to it. Consideration, though, should be given on the size of the amalgam that you've placed. It is usually used when you have a patient who cannot afford to put full coverage on that patient. Remember, though, that it's really hard to construct a crown to fit an existing RPD after the restoration of, under the crown or under that rest goes bad. Rests placed on sound enamel or on any restoration material, they're not subject to decay so long as the oral hygiene is maintained, but the proximal surfaces are the worst and most apt to be the ones to decay under those guide plane areas. If restorations are extremely large, then consider crowning that tooth. Rest seats should be made in the crowns in metal if you do a porcelain to metal crown. The best protection from decay is to completely cover the abutment tooth with a crown. It's absolutely necessary that these crowns be contoured properly to fit the design of the partial denture, and it should also include subgingival coverage with the crown. Economic factors, though, often dictate whether a patient can or cannot have tooth crowned, unfortunately. Rests are usually named for their position on the tooth. Occlusal rests are usually located on the occlusal surfaces of posterior teeth. The lingual or cingulum rests, sometimes called, are located on the lingual surfaces of anterior teeth. Most commonly, it's the canines on the maxillary arch, but sometimes the central incisors also. Incisal rests are placed on the incisal surfaces of the anterior teeth. Here are examples of the occlusal rest. The occlusal rest gives positive vertical support and is found on either the premolars or the molars. The outline form of the occlusal rest seat is a rounded triangular shape with the base at the marginal ridge and the rounded apex directed toward the center of the tooth. It is approximately 2.5 millimeters in width. Another way of stating its width would be to say that the width of the occlusal rest is about half the distance from cusp tip to cusp tip, or the width is also 1/3 the width of the tooth from buccal surface to lingual surface. The length of the rest and the rest seat should be 1/3 to 1/2 of the length of the tooth from the mesial surface to the distal surface. It usually fills the mesial or distal fossa, unless you're placing a long occlusal rest to prevent migration of a posterior molar abutment. The floor of the rest seat must be apical to the marginal ridge, and the occlusal surface is concave or spoon-shaped. Sharp angles must be avoided, or sharp edges must be rounded. You don't want to have any potholes or any vertical steep walls. The angle formed by the occlusal rest and the vertical minor connector from which it originates should be less than 90 degrees, directing forces along the long axis of the tooth. If the angle is greater than 90 degrees, as shown on the left, an inclined effect produces displacement of the prosthesis and can produce movement of the tooth. The deepest part of the rest seat should be located near the center of the mesial or distal fossa. The rest must be between 1 and 1.5 millimeters thick where it crosses the marginal ridge. It must be a minimum of 0.5 millimeters thick at its very thinnest point, which would be in the fossa portion. Reduction must equal the replacement of the rest. In other words, the occlusion should be unaffected because we have reduced the tooth by at least the amount that we have replaced with a rest. Here is a summary of the form the occlusal rest and rest seat should take. The marginal ridge reduction is 1 to 1.5 millimeters. The fossa reduction is about 1 millimeter. The floor of the rest seat is apical to the marginal ridge, and the rest is spoon-shaped or concave. We have to avoid any sharp angles and round all corners. It should hold a BB if you were to place something in that fossa. It should not roll off because the fossa is deeper than the marginal ridge. Failure to reduce the marginal ridge will result in thin areas where the metal of the minor connector joins the rest. Failure to reduce the marginal ridges will result in a framework that's in occlusion when it's returned from the laboratory and tried in the patient's mouth. A minimal thickness of 1.5 millimeters of chrome cobalt metal is necessary to prevent fracture of the framework under function. Placing an occlusal rest on a large amalgam is hazardous. The only reason you might be considering this is for economic reasons. The patient can't afford it at the time. But if you use this approach, you must remember that replacing the amalgam if it breaks under the RPD is very difficult, and retreatment of the restoration on the abutment may result in the fabrication of a new RPD, which is very costly. Placing a crown under an existing RPD is very difficult. A conservative amalgam may be used, but consideration of a casting for the tooth should be considered for the long-term success and possible economic values. In the Kennedy Class II Mod 1 and Kennedy Class III arches, where the most posterior abutment is a mesially tipped molar, an extended occlusal rest should be designed to minimize further tipping of the abutment and to direct forces down the long axis of the tooth. The long occlusal rest extends to the distal fossa of the molar. You may also place an overlay on the tooth if it is out of occlusion and you want the rest waxed up to provide occlusion with the opposing arch. The rest is waxed and cast with the framework in the form of a tooth's occlusal surface, and it is waxed into occlusion with the opposing arch. The case has to be mounted when the framework is sent to the laboratory for fabrication. If upon examination of the mesially tipped molar, it is determined that it is impossible to prep an acceptable rest seat on the mesial occlusal surface due to the tilt of the molar mesially, occlusal rest may be placed on both the mesial occlusal and the distal occlusal surface to support the restoration and direct the forces over the most root surface of the abutment. A ring clasp is an example of using this philosophy. It prevents further tipping of that molar abutment. You must prepare the rest seats, though, in the same angulation as the path of insertion for the removable prosthesis. Another type of rest is an embrasure rest or interproximal occlusal rest. It's used when we bring an arm or two through the embrasure of two adjacent teeth. Whenever we come through two adjacent teeth with a direct retainer or a reciprocal component, we must place a double rest to avoid the feeling of wedging that the patient would get if we have just a single rest. It's much like if you place a toothpick between your two teeth and get it caught and wedged there. That same feeling takes place if we don't use a double rest. The embrasure form of a rest provides a room to continue the arms of the direct retainer and reciprocal component through the embrasure without enlarging the tooth size and to keep arms from interfering with occlusion. With the rest, it recreates the original contour of the tooth. Take a look at the pictures on this slide for the embrasure rest form. The embrasure rest is prepared as individual rest, but are extended farther lingually and buccally to make room for the metal to pass through that embrasure area. It is used to avoid interproximal wedging by the framework. Think about it, if we only had one rest there, and the patient functions and that tooth depressed but the other one did not, it would feel like there's something wedging between the two teeth. If we place a double rest there, then when the patient functions, both teeth depress at the same time and eliminates that feeling of wedging the teeth apart. The marginal ridge of each abutment tooth is lowered 1.5 millimeters for strength of metal and to allow for occlusal clearance when the rest is placed back onto the tooth. The contact point cannot be broken when you prep these two teeth, or you will have an additional packing of food problems when the partial's not in position. The manner of preparation for the embrasure rest is as follows. You first reduce the marginal ridge by 1.5 millimeters on both of those teeth. Then you prepare the buccal and lingual openings called sluiceways. Then reduce the fossa 1 millimeter with a round burr. You want to check for clearance by having the patient close together, and at the same time you should be able to put a perio probe through from buccal to lingual surface if you have enough clearance for the metal of the embrasure rest clasp. Pictured here is the lingual or cingulum rest. This particular rest is a rounded chevron that is used on the maxillary canines. It may also be used on the mandibular canines if a cast restoration is placed on the tooth or if a composite cingulum rest has been placed on the tooth. The lingual or cingulum rest is used primarily on the maxillary canines due to morphology. The maxillary canines have a natural cingulum where the enamel is relatively thick. On the mandibular canine, the enamel is so thin that you would run the risk of perforating into the dentin. If that happens, a framework that goes in and sits on the dentin is quite painful and really pretty unbearable for the patient. The lingual rest on incisors are rare. You may find them on the maxillary central incisors periodically, but they are not used on the mandibular laterals or centrals nor on the maxillary lateral incisors. The rest on the mesial fossa of the first premolar is preferred on that mandibular because there's no occlusion in that area and you don't have any problems with placement and running the risk of perforating the dentin. A lingual rest is preferred to the incisal rest because the lingual rest is located closer to the center of rotation of the tooth and has less tendency to tip the tooth. It is also more aesthetic. You will sometimes see board questions related to these facts. The maxillary cingulum rest form is a rounded inverted V, or I prefer what would be considered a chevron shape that is rounded. It follows the natural contours of the cingulum at the junction of the gingival and middle third of the tooth. It's a minimum of 2.5 to 3 millimeters in width, and this V, or chevron, prevents mesiodistal movement of the RPD. The labiolingual depth is about 1.5 to 2 millimeters, if you look at the illustration above. The shape prevents labial lingual movement of the prosthesis. The third point is the incisal apical depth, which is about 1.5 millimeters. It's deeper at the point shown by the arrow, so that it provides a positive seat that if you tried to hang a coat hanger on there, it would not slip off. It prevents the tooth from moving away from the framework as pressures are exerted on that lingual rest. You do not want to attempt the mandibular canine preparation of this particular rest because the enamel is very thin where the rest would normally be placed. If you look at the picture on the left, this shows an adequate preparation of the cingulum rest seat. It assures axial loading. As a force is applied to the partial denture, the forces are directed down the long axis of this tooth. It is also prevented from moving labially because there's that positive rest seat on the back. If we could actually hang a little hanger on the back of there and it would not fall off. It also prevents settling of the denture into the soft tissues and prevents damage to the tissues. On the right, we have what I'd like to call a leaner. There's no positive support on that partial denture. If a force is exerted on that partial denture, that tooth would have a tendency to move to the buccal because of the inclined plane that has been created. When a cast restoration is considered and planned, the wax pattern should display the proper contours prior to casting the crown. When I order a porcelain fused to metal crown on a canine, I always ask for a cingulum rest to be placed on that crown. I ask for a rounded chevron shape rest seat to be placed at the junction of the middle and cervical 1/3, and for a positive rest seat to be 1 to 1.5 millimeters in width and exhibit a less than 90-degree angle to the positive seat. To summarize the cingulum rest, cingulum rests are preferable to incisal rests because they are nearer to the axis of rotation, exerting less force on the tooth. Usually they're confined to the maxillary canines, but there are a few central incisors that have a prominent enough cingulum to warrant placement of the rest. Usually they're about at the junction of the cervical and middle third, but they must be constructed avoiding damage to the occlusion. You cannot lose your positive stop for the opposing arch tooth. So mounted casts are absolutely necessary. Any potential rest seat must be evaluated to see how it affects the occlusion of the two arches. You can't lose your positive stops. This is our distal incisal angle rest. It is placed on that distal corner of the canine. It is a positive rest seat. It's placed there because the canine turns the corner of the mouth, And if you put it on the distal, it's a little less noticeable than if you placed it on the mesial. It's placed on mandibular canines, never on central incisors or lateral incisors, and never on maxillary canines. It would be very ugly. The distal incisal angle rest form is as follows. Be sure to create the guide plane first. It is a rounded notch at the incisal angle of the mandibular canine. Its deepest point is apical to the incisal edge, and the wall is closest to the long axis of the tooth. The depth from the proximal surface toward the middle is 1.5 millimeters to 2 millimeters according to our text. I think 1.5 is plenty. The floor of the rest seat, as shown in the middle picture, is extended slightly to the facial and to the lingual surface of the tooth, and those edges are rounded toward the facial and the lingual. The angle of the prep is slightly less than 90 degrees so that you have a positive rest seat, and the line angles are all rounded as shown with the dark shading. A slight bevel is on the buccal and the lingual surface, and it's created by your slight rounding of that facial and lingual edge. Pictured here is an incisal rest. The incisal rest can be on that mandibular canine and located anywhere along that incisal edge. It differs from the disto-incisal angle rest in that it is not placed right at that distal incisal angle corner of the canine. They are not placed on mandibular incisors or lateral incisors, and they really are not placed on any of the incisal edges of the maxillary teeth because of aesthetics. The incisal rest can be placed on the mesial incline or the distal incline of the canine. One thing that may affect that is occlusion. The width of the preparation is about 2.5 millimeters wide, and the depth is 1.5 to 2 millimeters. It is beveled on the labial and lingual surface, and you can kind of get a hint of this by the shading that's on the tooth above. It is not as aesthetic as the distal incisal angle rest because it is a little bit more hidden. The distal incisal angle rest is a little more hidden. Remember, these dimensions are necessary because of the occlusal portion and the occlusion on the opposing tooth. You have to reduce enough room to replace it with the metal to fill the tooth back to its original contours, and you must have about 1.5 millimeters for strength on this rest. A fossa rest is sometimes used on an anterior tooth when the cingulum rest is contraindicated because of tight occlusion. It is a prepared rest seat that looks similar to an occlusal rest, but it must be prepared to have a positive seat directing the forces down the long axis of the tooth. If it's not properly prepared, it becomes a leaner, and that tooth can move labially under occlusal forces on the prosthesis. Implants and endodontically treated tooth roots can be used as rest. When implants are used, the implant eliminates compression of the soft tissue, it controls vertical movement of the denture base, and it eliminates or alters fulcrum lines and serves to increase support and stability of the prosthesis. Attachments can be added to both implants and tooth roots to help secure the partial in place for retention. The authors of a research study recommended placement of implants under individual extension bases and listed several advantages, those being increased stability of the RPD, diminished alveolar resorption, increased retention, reduced stress on the natural abutments that remain, reduced need for clasping, and improved patient comfort. When you come into the clinic to do mouth preparation or reshaping the teeth, It's absolutely essential that you bring your diagnostic cast and that they be available during mouth preparation. Also, the surveying table should be readily available to you so that after you do some mouth preparation, you can take a quick snap impression, pour it up, and in 5 minutes look at what you have achieved and see whether additional reduction is needed. As you go into clinic and start mouth preparation, the first and most important rule of thumb is to be conservative. Also, ask for evaluations along the way. First, I would prepare mouth preparations on a duplicate of my diagnostic cast. That way, when I go into clinic, I have an idea of the direction in which I'm going, and I can get an evaluation from the faculty member to start off and see whether I have the right track in my mind. Remember that you can only prep on enamel. If you get into dentin, it will require a restoration of some sort. After the enamel has been prepared, we're going to ask you to finish up with a polish, and that is done with a carborundum impregnated rubber wheel or rubber point that's placed in a low-speed hand paste. You'll use light intermittent pressure and moderate speed during the polish. If it requires more than just a minimal amount of reduction, then you might want to consider something like a restoration as in a crown for the tooth if it's going to need considerable adjustment. When you do mouth preparations, it's absolutely necessary that your diagnostic cast be present, and you must orient it on the surveyor table at the desired path of insertion that was determined during your original survey when the design was drawn. What this does is it allows visualization of the cast to allow you to create guiding planes and other contours that are in harmony with your planned path of insertion. There's an order in which rest preparation is done, and they are listed above. First, the proximal surface is prepared parallel to the path of placement to create a guiding plane. Next, the height of contour on the buccal and lingual surface is lowered when necessary to permit the retentive clasp terminus to be located within the gingival third of the crown, and the reciprocal clasp arm on the opposite side of the tooth to be placed no higher than the cervical portion of the middle third of the crown. Next, the area of the tooth at which the retentive clasp arm originates should be altered if necessary to permit a more direct approach to the gingival third of the tooth. Fourth, undercuts for retention can be placed on one of the buccal or lingual surfaces of the teeth. And lastly, the occlusal rest itself will be prepared on the tooth to direct forces down the long axis of the tooth. A guiding plane next to an extension base can be slightly shorter than one that is next to an edentulous area next to a tooth-supported abutment. Typically, it can be 1.5 to 2 millimeters in height on the extension base abutment and 2 to 4 millimeters on the tooth-supported abutment, according to our text, the Stewart text. I don't really like to see them any shorter than 2 millimeters. On the lingual surfaces, you will sometimes find guiding planes associated with plating or arms for reciprocation. They may help ensure that the reciprocal component protects the tooth from movement when the direct retainer slips over the height of contour. A second reason for a guide plane on the lingual is that it limits the number of pathways that the RPD can be seated, and that increases stability. A third is that it provides maximum resistance to lateral forces. Our text says that the direct retainer retentive clasp arm should be located no farther occlusally than the junction of the gingiva and middle third. It serves the purpose that it improves appearance and mechanical characteristics. The amount of correction that can be done is limited by the amount of dentin or enamel in the area. You cannot go into the dentin. In the event that you do perforate into dentin, a restoration must be done. The proximal surface tooth preparation is best done using a tapered diamond in a high-speed handpiece. Note that it follows the contour of the tooth. Look at figure 2 above. It is followed by polishing the tooth with a rubber point to make it smooth. A guide plate on the anterior tooth should extend as illustrated on number 2 above. It stops just lingual to the cusp tip so that the metal does not extend where it becomes visible and unaesthetic. This can vary, though, if the tooth next to the edentulous area has leaned dramatically to the mesial. Sometimes that happens. And then we extend the guide plate more facial to remove tooth structure to gain some lost room in order to place a tooth in the space that offers the most aesthetic result. You must analyze and preferably diagnostically wax up the tooth setup prior to tooth alteration. You will then know what is necessary to be done to give the aesthetic result that you desire. Let's say that you've prepared your rest prep first on the left, and you have the marginal ridges a little higher than the fossa, and a nice little BB can sit into that fossa. Well, if you did the rest prep first before you did the guide plane, and you come back through with that tapered diamond, you may eliminate that marginal ridge area, and the BB will roll off. Your rest prep then no longer has a positive seat. It's more like an inclined plane. This slide makes the same point. You have gone ahead and prepared your rest prep first on the tooth on the left. Then, when you come back to prepare the guide plane, you may wipe out part of your rest and have to re-prepare that tooth surface, and sometimes that's disastrous. This one maybe is a more easy fix than in other cases, but the guide plane is done first. You need to prepare guiding planes. A guide plane is defined as 2 or more parallel vertical surfaces of the abutment teeth, so shaped to direct the prosthesis during placement and removal. These 2 guide planes must also be prepared to coincide with the path of draw or placement for your partial denture. Each wall is said to be parallel to one another, but there is a slight degree of taper to the amount of about 5 to 7 degrees, which corresponds to the prepping burr, which is a tapered diamond or tapered fissure burr. The function of the guide plane is to 1. Provide one path of placement for the removal and placement of the partial, 2. To ensure the intended actions of the reciprocal or stabilizing and the retentive components are achieved, 3. To eliminate food traps between abutment teeth and the parts of the partial denture. The proper dimensions of the guiding planes are 1. It is 1/2 the width of the distance between the buccal and lingual cusp tip, or 1/3 the width of the tooth from the buccal to the lingual surface. It extends about 2/3 of the length from the marginal ridge to the cervical of the tooth, providing you don't have to mutilate the tooth in order to get that type of length. It often extends only 2 millimeters in width from the marginal ridge to the cervical portion of the guide plane on an extension-based partial denture, but you'll find that on the tooth-supported partial denture you want a little longer guide plane of about 4 millimeters in width. It is located on the abutment tooth surface that is adjacent to the edentulous area. It's wide enough to use the guiding plane to full advantage, and it should be tapered to the tooth below the origin of the clasp arm. There are 3 philosophies as to where the guide plates are to be placed. When we discuss the I-bar concept, we will be following the positioning of the guide plate as shown in the upper right picture, which states that it will rest on the tooth for 1 millimeter in width, just above the bottom of our guide plane preparation, which is 2 to 3 millimeters below the marginal gingiva. The second philosophy shown in the upper left picture is that the guide plate touches the distal surface of the tooth apically to 3 to 4 millimeters above the marginal gingiva, and relief is placed in that 4 millimeter area to allow for escape of plaque and debris. If you wish more stability of the prosthesis, this would be the way you would place your guide plate, but it allows for greater torque to the abutment tooth. The third way is for the guide plate to extend from the marginal ridge all the way to the gingiva, as shown in the lower left picture. This will be a method we do not use. I would use my diagnostic cast to adjust guide planes on the maxillary and mandibular before preparing them on the teeth. This is an example of an excessively reduced guide plane. The guide plane should not extend more than 2/3 of the distance down the proximal surface. This allows for a space to be created in the gingival 1/3 of the guide plate so that food and debris can escape at the cervical and not be shoved into the sulcus. Also, this tooth has been totally mutilated. The guide plate must be a minimum of 2 to 3 millimeters in width, so you can stop right there if need be, but don't mutilate the tooth. This tooth needs to be crowned now. Here's another example of an excessive guide plate preparation. See the red. If you carry the prep all the way out to the labial and you place metal all in that area, then the metal will show and you will not be able to butt a denture tooth up against that tooth, and you'll have this metal slit showing on your partial denture. Sometimes you want to extend the prep all the way out if that tooth has leaned dramatically to the mesial, but by and large you would like to stop that prep just lingual to the cusp tip, and you do not want it to extend all the way to the gingiva. You only want it to extend about a 2 to 3 millimeter area below the marginal ridge. The guide plate is prepared with a tapered diamond burr that is angled parallel to the path of insertion. It creates a surface that is relatively parallel to the path of insertion with a slight degree of taper of about 5 to 7 degrees. It is not positioned parallel to the tooth surface, as that can result in no change to the survey line at all. The guide plate in the upper picture is not a healthy situation. You do not want to have plaque and debris jammed into the sulcus due to the guide plate extending all the way down to the gingiva. The lower one has a space in the lower 1/3 so that the plaque and debris can escape from the sides as the framework is seated in the mouth. On the upper left, remember the rule that the first 2/3 of your direct retainer arm must be all above survey line. We drew a problem interference here. The top of that circle is where the current survey line is located. The bottom of the circle is where you want to move that survey line so that the first 2/3 of that direct retainer can all be above survey line. This area will be adjusted with a tapered diamond burr and laid along the facial surface of that tooth so that that survey line will be lowered the next time you place it on the surveyor after the mouth preparations are done. The bottom left pictures have the same problems. Again, the direct retainers cannot be, only the terminal third can be under the survey line for a cast circumferential. The wrought wire, half of it can be under the survey line. But in this case, those lines are very high at the origin of the direct retainers. So the survey line must be lowered to the point where it is below our clasp arm. And that again is done with our tapered fissured burr. On the upper right picture, we see a problem where our direct retainer arm would have to be way up almost on the occlusal surface. We have drawn it where it should be placed, but that line will have to be adjusted so that the origin of that direct retainer arm can be a little bit lower on the tooth. These are the 2B and C types of adjustments in the order of the rest preparation. Sometimes we have to place a groove in the tooth to create an undercut for retention. This is ideally done when the buccal and lingual surfaces of the teeth are relatively parallel to one another. It should exhibit smooth contours prepared by a round or a football-shaped diamond. The burr is moved anterior-posteriorly, parallel to the marginal gingiva, and it is located in the cervical 1/3. It is approximately 4 millimeters in length, fading out at the approach arm of the direct retainer. You have to be certain to create a .01 undercut, and it should be polished after the fact to create a nice smooth surface. Care has to be taken not to eliminate the undercut while actually polishing it. After A through D are complete in the order of rest preparation, you're now ready to actually prepare your occlusal portion of your rest seats, to prepare the Cingulum rest and the Incisal rest. We're now ready to prepare the occlusal rest. First of all, the marginal ridge is reduced approximately 1.5 millimeters to allow for sufficient room for metal to be placed that will have strength necessary to take the forces of the RPD on occlusion. The rest is approximately 1/2 the width from cusp tip to cusp tip. It may have sluice ways if buccal and lingual arms are on the tooth. The purpose of these sluice ways is to create room for the metal arms to be present and not enlarge the size of the tooth. The fossa on the rest is reduced at least 1 millimeter. The rest is spoon-shaped and has no steep walls that create guiding planes for the prosthesis. The fossa is deeper than the marginal ridge to create a positive support so that you could sit a baby on top of that rest and it would not roll off. If you look at the rest prep pictures above, you'll see all ranges of correct and incorrect. On the right upper maxillary tooth, there's insufficient reduction on the marginal ridge area. Any metal coming through that area will be insufficient in thickness, and the rest will probably break off. On the lower tooth, number 18, the reduction is excessive, probably into the dentin, and it has steep parallel walls that hopefully are in line with the path of draw, or the cusp may be apt to be broken off, inserting and removing the partial prosthesis. The rest on the left is ideal. It has sufficient clearance for metal in that area. It has sloped walls that do not have places where pressure would be placed on the buccal and lingual cusp, and it allows for seating of the partial without possible interference with the path of insertion. The Embrasure Rest prep form is shown on these pictures. I first prepare a marginal ridge reduction of 1 millimeter to 1.5 millimeters. On our dentiform, a little over 1 millimeter is adequate, or you will break the contact. You do not want to break the contact between the teeth. Then I use a rounded end large diamond to actually prep the sluice way by coming straight through that area. And I take a little bit off of each tooth, not all off of one tooth. Then I reduce the central fossas of the occlusal rest part to be a positive stop so that I could sit 2 babies on those individual rests and not have them roll together to meet at the center. If you have an inclined plane, then the tendency might be for those teeth to move apart and open up that contact area, which would be a food impaction area. When you have completed your Embrasure Rest, take a perio probe and insert it into the buccal sluiceway. That perio probe should be able to sink all the way to the depth of the handle without any interference and without opening the occlusion between the upper and the lower arch. If it will not sink without opening the bite, you have not prepared enough material away from the tooth in order for an arm to be able to emerge from that area without the danger of it being broken. Another common mistake that is made is that a sluiceway is prepared on the tooth that has an eye-bar restoration. For the eye-bar, there will not be an arm coming between those two teeth, so there's no need to prepare that sluiceway. So don't make that mistake. Remember that the maxillary canine has a natural cingulum, and you can prepare a chevron-shaped rest at the junction of the cervical and middle third. This one has a good shape. It has a rounded top. It's not a pointed area. When you take an impression of something that's really pointed up there, you probably won't have trouble in the impression taking. But when you go to pour it up, there is a tendency not to capture that little pointed area. And what happens is then you have a cast that has a rounded off border, and then the framework is made on it. And then you go to the patient's mouth, and if you have prepared a pointed area there and didn't capture it, your framework will not seat. So take this into account. Here are some examples of cingulum rests that had a little bit of a problem. On the upper right picture, this is very rough and has not been finished off properly. It also is probably undercut on that area to the left because the material on the tooth has not been removed sufficiently above the actual seat. On the left middle picture, it has a very weak cingulum rest that is really too high on the tooth, and it's under-prepped. It doesn't have a positive stop, or at least you can say it has a very weak positive stop. On the bottom lower left, you have some major problems on this one in that there's absolutely no positive stop for the framework on this. It's undercut from the path of insertion, and the frame will slip downward on the tooth and push it labially. Also, it's way too high up on the tooth. It should be down at the junction of the middle and cervical third. Look at the far upper right picture on this slide. This illustrates the depth that you should go into the tooth horizontally for the distal incisal angle rest. It is approximately 1 millimeter in depth. It can go up to 1.5, but depending on how deep you take it, you could run the risk of getting into dentin. The inner portion of that rest is slightly deeper than at the marginal ridge area. The depth in the bottom picture shows that the depth of the tooth prep is approximately 1.5 millimeters from the incisal edge. The middle picture on the bottom is an acceptable prep, as well as the one on the bottom left. Bottom left definitely shows that nice little positive rest seat where you could hang a hanger on there and you know that it's not going to slip off. The form on the upper left is a little bit too deep. I think the dentin would be exposed on this particular tooth, but it does have excellent form. And you can also see the little bit of a tapered groove that you see on the buccal and lingual surface that gives it that positive seat buccolingually. Here are a list of references that you may find helpful when getting ready to do mouth preparations for removable partial denture.